So the range from warm-up, what was the highest soccer player, or the highest, who's the lead scorer besides Mr. Franco? What's the last name? Lukaku?
Lukaku.
Oh, sorry. Is it 20? Is it 24?
Yeah.
There was actually a very famous player named Kaká. Does he still play?
MLS.
He's still playing, huh?
Yeah.
Yeah, he used to be real good. I'm not sure how good he is now.
I taught him everything.
Why are you so arrogant and conceited? Never mind.
Is that all?
24, watch this. So the range, again, the range of any data is the highest and the lowest. How far apart are the highest and lowest values? Well, you just subtract the two numbers. Okay, so 24, we're going to put highest goals. So again, this area of the note paper is for you. That's why it says your notes here. Okay, so off to the side, you're doing this with me. So highest goals minus 14. Gracias. So the range then is going to be 10. That's your range. You just take the highest data value, subtract it from the lowest data value. I'll put lowest. And that's how you get your range. Very simple. I mean, this is not high-level math here. Take the highest, subtract the lowest, that's your range. Range is like how spread out, like from what to what, what's the distance between the highest and lowest, okay? Moving right along. Moving right along. Third word. Third and last word of the day. Standard deviation. The typical difference between the mean and a data value. The typical difference between the mean and a data value. The typical difference between the mean and the data value. The formula, I'm going to throw a formula at you for standard deviation that looks very frightening and scary. It's actually scarier than it actually is. It looks scary, but it's nothing. It's very, very easy. Okay, and this standard deviation formula or recipe, because the formula is just like a recipe. Like if you want to make brownies, put so much eggs, sugar, this and that, and you get brownies. I'm going to give you the recipe to find the standard deviation of any data set. And we're going to do one example with that recipe, and we're done for the day. So we just had 3 words today, and I'm going to give you one example. Now this example, you should put on a separate sheet of paper because it takes up a lot of space. So in other words, you're not going to be able to use that side area of your note paper. Put this example on a separate sheet of paper. Okay, here we go. We're going to do the MLS or the Premier League data. Here we go. So standard deviation, ready? Standard deviation. The word deviation means to stray away from something that's normal. Sometimes people display what we call deviant behavior. That means behavior that's not normal. If you're showing up to class once a month, that's deviant behavior. If you're not listening to your teacher and trying to pass and graduate high school, that's you're straying away from what's normal. Okay. Sometimes people on the bus, public buses, display deviant behavior. You know what I mean? If you've ever taken the public bus or public transportation, there's some strange animals in there, some strange people. But, so standard deviation, we're talking about something straying from something. I'm going to get into that when we're done. But deviate means to stray away from something that's normal. Watch. And here's the formula. Again, it looks scarier than it actually is. You guys ever seen this? Don't write this down. You guys ever seen this letter? Pi. That's actually a letter from the Greek alphabet. The Greek alphabet has a bunch of strange-looking letters, and one of them is pi. Okay, Greek is a very ancient language. The Bible was written, the New Testament was written. It's very ancient, and we use a lot of the letters to represent mathematical truths. Pi was 3.14, and we use that to find the area of a circle and the circumference of a circle. Standard deviation, there's a Greek letter that we use to designate standard deviation, and that letter is sigma. Looks like an O with a little tail there. Okay, so standard deviation equals, ready? Here we go. Here's the formula now. Here's the recipe. How do you find the standard deviation of a set of data? Ready? Let's do this. You're going to take the square root of some stuff. The square root. Yeah, it's a big square root because I'm going to put a lot of stuff in there. Again, this recipe looks scarier than it actually is. Okay, now, I'm going to put a big fraction in this square root. There's some stuff that's going to go in the numerator and some stuff that's going to go in the denominator. The stuff on the numerator is going to be this. It's going to be another Greek letter, which is sigma, uppercase sigma, which this means the sum of. Just add stuff up, right? And you'll see this when you get into higher level mathematics in college. If you see this uppercase sigma, that means add a bunch of stuff up. Summa, add a bunch of stuff up. Well, add what up? Well, I'm going to right here, I'm going to tell you what to add up. Ready? You're going to add up every observation and how far it is from the mean. Look at x bar is the mean, right? That's what we learned yesterday. You're going to figure out every observation. How far is it from the mean? What's normal? Remember, the mean is like your normal, your average. How far is every observation from the mean? And you're going to square it, take it to the second power. And you're going to divide it by how many observations there are. Done. So this x means each data value. You want to write nice and big. Each data value. X bar, that means your mean, right? Your average. And we went over yesterday is the number of observations, or number of data values. Cool? Write that down nice and neatly because you're going to be using this a good amount of time, especially in that assignment 9. All right, let's go ahead and find the standard deviation of the top 10 scores of soccer players, Premier League. So, we're going to add up, that's the sum, we're going to add up each data value. We already know the data values. It was from 24 to 14. There's 10 of them. We'll take each data value and subtract the mean. What was it? What did we find out the mean was in the warm-up? 17.9, right? So 17, this would be 17.9. And then what's n from warm-up? There's 10. There's 10 players. Okay, so really it looks scarier than it actually is. You're going to add up stuff. That's what uppercase sigma means in Greek. Each observation, how far is it from the normal, the average? That's what mean means, the average. How far is every observation from the average? We'll square it. We'll divide it by how many players, and we'll take the square root of it in the end. Okay, it's going to be okay. Stay with me. Now, you guys just said x bar was what? What was x bar? 17.9. Now, for our sake, so the average was 17.9 goals out of all the top 10 players. So the top 10 players 17.9. What we're going to do is we're going to just round this to the nearest whole number. So I don't have to work with decimals. It makes life more difficult when you have to work with decimals because typing the calculator is annoying. So let's just, x bar is 18. Okay, 17.9 is almost 18. We'll round the nearest whole number. So for this example, we'll just say the average is 18 goals. The top 10 Premier League goal leaders, the average is 18 goals. Now, here we go. Let's find the standard deviation, sigma. Here we go. You're going to need a lot of space horizontally here. Ready? I'm going to write kind of small. Sigma equals, watch this, the square root, look how long this thing is going to be. Again, it looks scarier than it actually is, but it's really simple. Okay, who's the first player? 24, huh?
Yep.
So look at how far is 24 from the mean? The mean is what again? 18, we just figured that out. The mean is 18. So how far is 24 from 18? Now square it. Plus, what's the second guy in second place? 21 goals?
Yeah.
So 20, how far is 21 from the mean? 18. Square it. Okay, so far so good? Stay with me, guys. Plus, third place. Who's third place? 19 minus 18 squared. Fourth place? 19 minus 18 squared. Fifth? 18 minus 9, 18 minus 18 rather, squared. Sixth place?
17.
Thank you. So 17, so I'm taking every data value and I'm subtracting the mean. 1, 2, 3, 4, 5, sixth place, seventh place, Uncle. Gracias. 17 minus 18 squared. Eighth place?
15.
Minus 18 squared. 15 minus 18 squared, I'm going to barely fit it. And then 14, right? The last place is 14 minus 18 squared. Whew. Just fit it there. That's all my numerator. Remember what we wrote down, the sum. I'm adding a bunch of stuff up. I'm adding them all up. Every data value minus the mean. In other words, how far did every data value stray away from what's normal? I'm showing them standard deviation, Doug. Oh, Ms. Rose. Okay? Again, this looks a lot more frightening than it actually is. Uppercase sigma, we're adding stuff up, adding a bunch of crap up. What's the crap that we're adding up? Look at it. How far is every observation from the center? That's all that's in these little parentheses. Nothing crazy. Okay? Now, that's just a numerator, right? Here we go. Look at this nasty denominator. How many players were there? 10. Here we go. Sigma. Here we go. Let's simplify. I'm going to simplify everything in little parentheses. Every single parenthesis is how far every player was from the average. Right? Every player from the average. So let's see. The top scorer from the average, how far away was he? Let's see, 24 minus 18, 6. And I'm going to square it. Look at this. Square that puppy. Plus, how far was the second place goal scorer from the average? Let's see, that's 21 minus 18. That's 3, right? 19, 20, 20, yep, 3 squared. What's up, Rico? 19 minus 18 is 1 squared. Right, Vasquez? So 19 is 1 away from 18, so that's 1 to the second power. 19 minus 18 again is 1 to the second power. See, it's really not that big of a deal. Again, it just looks scarier than it actually is. It's just a bunch of And you follow, please excuse my dear Aunt Sally, the order of operations, right? That's all we're doing here. Nothing crazy. All right, so that's first, second, third, fourth, fifth place. 1, 2, 3, 4. 18 minus 18 is what? 0, huh? So 0 squared. 17 minus 18 is negative 1 squared. 17 minus 18 again is negative 1 squared. Stop me if I'm going too fast. 15 minus 18 is a negative 3 squared. Again, another negative 3 squared. 15 minus 18 and 14 minus 18 is a negative 4 squared. Now, this is a lot of work. And after I show you how to do this manually, the long way, I'll just show you how the calculator can do it like in one button. But that wouldn't be education, would it? It'd just be showing you how to press a button. So I'll show you how the calculator can do this in one shot, quickly, before I teach you how the formula works. Yeah, because this is like school and stuff, and you're supposed to like learn and stuff. Not just press buttons. Here we go. All that crap divided by 10. It's 10 players. 10 soccer players. Let's keep it going. Let's simplify now. Sigma, standard deviation, is okay. What's 6 to the second power? You're awesome. Remember, this doesn't mean 6 times 2. This means 6 times itself, which is 36. Plus 3 times itself is 9. 1 times itself is 1. 1 times itself is 1. 0 times itself is 0. Negative 1 times negative 1. What is negative 1 times negative 1? Former graduate. Another 1. A negative 3 times itself. Negative 3 times negative 3. Positive 9. Another positive 9 here. And then I got a positive 16 here. The further we go in this formula, if you notice, the more and more it starts looking like kindergarten math. Now look at, we're just adding a bunch of numbers. Divided by 10, yeah? Let's do this. I'm going to simplify the numerator now, the nasty looking numerator. 36 plus 9 plus 1 plus 1 plus 1 plus 1 plus 9 and 9, that's 18, plus a 16. I got an 83. So the standard deviation is the square root of 83 divided by 10. So far, so good? So the standard deviation then is the square root of 8.3, because 83 divided by 10 is 8.3. Let me type 8.3 into my calculator and hit the square root button. I'll round the nearest tenth. 2.9. So the standard deviation then is 2.9. There he is. Give his monthly visits. Gotta get here in a minute. All right, so what does 2.9 mean? Okay, big deal. All right, yeah, we did all this arithmetic gymnastics. Look at all this crap we did. Hey, man, let me talk, thanks. Look at all this crap. All this irritation and tedium just to get one number. What's the big deal, Mungia? What's the big deal about that number? It's 2.9. What does that mean? Here we go. Here's what it means. You can write it in one sentence with me. Each player, really soccer players, these Premier League soccer players, each player, here's what it means now. There's 10 of them. Each player is, on average, 2.9 goals away from the mean. Each player is on average 2.9 goals away from the mean. Remember the mean was 18? That was like the center. Out of all the data, the center was 18. Each player is about 3 goals. 2.9 is about 3 goals. About 3 goals away from the center. So it kind of gives a statistician, a professional statistician, people make a living at doing statistics. It gives a professional statistician an idea of how spread out the data is. The bigger this number, the more spread out the data is. The smaller this number, standard deviation, the more compact and compressed the data is. Like the data is hanging out together, real close together. Bigger number, data is spread out. Small number, data is compressed and compact. That's what standard deviation means. Okay? When you guys get to university, you will take, everyone has to take advanced statistics, whether you're a math major or not. You'll delve deeper into standard deviation. It's a big, big deal when you get to higher level statistics. Ask Mr. Caldwell. He can attest to that. He's in college right now. Yeah.